Hello everyone, welcome back. We're going to finish off section 6.1 with 3 more examples. They're listed as E, F, G on your sheet. You've seen I changed them to D, E, and F instead of D. So the first one here, you'll notice that there's going to be some factoring involved, like I mentioned in the previous video. So we have x squared minus 5x minus 6 over x squared minus 36. So what we need to do is, before we start, we can't just start dividing numbers, right? They have to be in factors. We can divide factors. So what we need to do is we need to factor them first, obviously. So we have a trinomial there. So you'll notice that trinomial is pretty easy to factor. You probably said 2 numbers multiplied together to give me negative 6, added together to give me negative 5. Yes, it's simply negative 6 and positive 1. So what we're going to do is I'm going to steal that from above, just so it'll save me a little time. So it's going to be x minus 6 bracket x plus 1. There's 2 factors. And the denominator, as you probably recognize, is the difference of squares, difference of perfect squares, right? So that's going to be x minus 6, x plus 6. And if you want, you can put in the values that x cannot be. So it's nice to factor that so you can see that it's negative 6 and positive 6. You can express it like this, or you can just put plus or minus 6. It's up to yourself. Alright, so this is stating the non-permissible value, so x cannot equal negative 6 or positive 6. We get that from the original, or if some people like to factor, it's easier to see. And then you'll notice that there's a common term in the numerator and denominator, the x minus 6 and the x minus 6, so they can be divided because they are essentially equal to 1. So I'll steal this again, and we'll write this in, and that means that x minus 6 is divided by x minus 6, and leaves you with 1, and you're left with x plus 1 or x plus 6. I like to leave the brackets. Again, it's completely up to yourself, whether you decide to or not. There's your simplified answer. It can't be simplified anymore. And there are your values of x that will not work. Alright? We'll explore more of these in Pre-Cal 12, and there's some neat things happening with these graphs. We're not going to see that this year. We're going to do those next year, unfortunately, with the loss of time. But you'll see those a little later on. Okay? So that's it. It's finished. There's your non-permissible values. They're the restrictions, right? And there's your simplified expression, x plus 1 over x plus 6. Okay? The next one we have is an interesting one. I'm going to put the values that don't work first. Obviously, it can't be 9. Oh, sorry about that. So x can't be equal to positive 9, as you can see from there. So I'm going to steal that. X can't be equal to 9 because if 9 subtract 9 will give you 0. So that is why that is the case. Now what we're going to do is we're going to factor the numerator and denominator if possible. So I'm going to steal a fraction here. Again, this is me taking that. It's not the answer by any means. So the numerator we know is difference of perfect squares, so it's x plus 9, x minus 9, it doesn't matter. And the denominator, you look at it, the x second is minus, so what we do to fix that, we take out a negative. Very simple. And then we have x, and obviously minus 9, because a negative multiplied by a negative gives a positive 9 back, and we'd like to rewrite it in the correct order. Okay? So, now the x minus 9s will divide, so I'm going to steal this again. So this x minus 9 divide with this x minus 9. And leave you with not just negative, we put a negative 1, but we can rearrange this and simplify it down to putting a negative here and get rid of the denominator altogether. So it'd be negative bracket x plus 9. And some people need to bring that further. Say that it's negative x and that's fine. Either one is minus bracket x plus 9, but it's the same thing. It's fine. Okay? The next one, what we'll do is, it's obviously hard to state the restrictions first, so obviously we're going to factor first. Now, f is, it's a little more difficult, of course. You have a values that are obviously greater than 1, so you're going to have to use decomposition. I'm not going to do the decomposition for you. That is something you should know at this point in time. All right? So I'm going to just grab a fraction over here. Just so the numerator is, obviously you can't factor out 3. Remember, we try to factor out a GCF first. 3 and 8 don't have a GCF, so obviously that can be done. So then we figure out two numbers multiplied together. Look at 3 times negative 3 would be negative 9. Add it together to give me negative 8. So decomposition will work with the numerator. So it's going to become, remember we just write 3 x squared, and the b value, the negative 8, that is going to be broken down into, remember it was two numbers multiplied together to give us negative 9, and 3 times negative 3, added together to give me negative 8, so yes, it's negative 9x plus 1x minus 3, so there's the decomposition. The denominator looks like decomposition, and you can use decomposition, however, remember the trick, if you can factor a GCF out of the 3 terms in the trinomial, do that first. And of course you can. 3, 15, and 18 are all divisible by 3. So we'll factor out of 3, and we're going to be left with x squared. I'm going to steal some terms here. X squared minus 5x plus 6. So I factor out of 3 in the denominator. So I'm going to recopy this for our next line. Still hard to state the restrictions because we haven't fully factored the denominator yet. So now we're going to use decomposition. So the 3x squared and the negative 9x, we can factor out of 3x, leaving us with x minus 9. Sorry, x minus 3, my apologies. And then obviously there's nothing in factor, but you still have to show a factoring out of 1. That's important. If not, you will get lost. So take the 1 and show the factor. Remember, when you do decomposition, you want to have the x minus 3 in the numerator there, and then we can group those together. The GCS we pulled out of both. So next, two numbers multiplied together for the denominator to give us 6, added together gives negative 5. You would be right, it would be negative 2. Negative 3. So this denominator factors to x minus 2, x minus 3. Alright, let's clean up that numerator a bit. The denominator's finished. Nothing else we can do with that denominator. But the numerator, however, remember we got to group the two GCFs, so the 3x and the x, the 3x and the 1 that we factored out, that becomes 1 factor, 3x plus 1, and remember we did decomposition, and there's where you end up with the numerator. Now you'll notice that the numerator, and now is a time where you can figure out the two values of the restrictions. We'll do that at the end. So the x minus 3 and the x minus 3 will divide out, leaving you with last step, x minus 3 divides with x minus 3 and leaves you with 3x plus 1 over 3 bracket x minus 2. You can't lose the brackets here because it's multiplied by 3, of course. That is completely simplified, right? And now we'll state the two restrictions. A little easier to see now, obviously. Right here, or it's right here. So x can't be 2 because that would give you 0, and x can't be 3, that would give you 0, so it's 2.3. So here is our simplified expression, and here are the restrictions on the denominator, which causes us to have a 0. So that is E, F, and G. On your page, I fixed it to D, E, and F. For homework, these are some worthwhile exercises for 6.1. Is numbers 1 through 4 and 6 through 8 on page 317 of your textbook. So that's it. The next video we will look at 6.2, where we're going to multiply and divide radical expressions, and we're going to go back to middle school for a minute, and we're going to multiply and divide fractions, just to make sure we know some of the rules that pertain to those. So thank you very much, and we'll see you in the next video of 6.2.